Hi, welcome to EROTECH Solutions. In previous sessions, we discussed about timers, counters, interrupts, and serial port blocks. So now I just want to give the complete overview on this complete 6 features of microcontroller. So you have the 2 different memories, RAM, ROM, and I/O ports. So timers, counters, interrupts, and serial ports. So you have the complete discussion on SFR registers and the features and how the features are working with microcontroller. So you have the complete SFR registers explanation, TMOD, TCON, and IE, IP, and SCON, SBUF. So all these SFRs which are preferably used for programming. So whenever you are looking to access any feature from microcontroller, so it's very important to learn about the related SFR registers. Okay, so now we are trying to deal with some applications with microcontroller. See, I just want give the complete interfacing with any peripheral. Okay, so don't like by heart the things. If you are trying to interface a peripheral or a module or a sensor or a display with microcontroller, so you need to understand some circuits in between controller and your external module. Some cases you are directly connecting with the microcontroller, and some cases you are going to prefer some external circuits in between input and output devices with the microcontroller. Okay, so again the purpose of memories is very clear. Whereas RAM memory used for temporary storage, which is used by variables declared in the program, and ROM memory used for program storage, so which is used for whatever the application file, which is the hex file which is created. You are trying to store that .hex file in the microcontroller with the support of ROM memory. And whereas I/O ports, which are used for external peripherals like sensors, displays, motors, relays, whatever you are trying to connect with microcontroller, you need to use I/O ports block. Okay, and timers purpose is very clear, which are helping us for generating accurate time delays, like maybe the seconds or minutes based on your application. Whatever the time delay you are looking, you can generate by using timers. And counters are extremely used for counting the external objects, like maybe sensor pulses or any visitor counter system. So all these applications we will discuss one by one. Okay, and the next interrupts block is very clear. Whenever you have the high priority task from your application, so you need to focus on interrupts block from the controllers. Okay, and serial port, which is helping us to communicate with external modules through protocol support. And what is the existence protocol in 8051, which is UART protocol. Okay, so this is a simple overview on features. Now I'm trying to deal with interfacing concepts. So maybe you have different interfacing concepts with microcontroller. So this topic don't have any limit. Okay, so because time to time the sensors which are changing and displays which are changing and the input devices which are changing according to the application. Okay, so I just want to give is like the standard applications, like how to approach displays and how to approach keypads and how to approach keys. Okay, so these are all you are going to learn one by one, and the topics are very clear. I'll go with LEDs. And whereas in LEDs interfacing, you are trying to discuss on how to deal with traffic signals as prototype applications, and the formations, LED formations, like in all decoration systems. So how we are trying to use LED formations and how to manage RGB, whereas different color LEDs, so red, green, blue. Okay, so these are the simple applications I just want to give based on the simple LED interfacing. Okay, and the other thing is indications. Okay, so because LEDs you are finding in different applications as a indication part. Okay, so based on the system, like you have a system in your home. If the system is working properly, which is showing green color. If the system have some fault, which is showing some like orange or any yellow, so based on the relative indicators. And if the system has damaged, which is going to show red indicator. Okay, see, how the system which is getting these indications properly, okay, based on the system status. Okay, in all cases you are not finding text screens and you are not finding image screens. Okay, so based on application they may prefer a different LEDs for different requirements. Okay, so now you will find different applications in these combinations, whereas traffic signals. So how to show traffic signal with the help of simple LED programming. Okay, so that is the reason your LED programming is also very important for us whenever you are doing applications. Okay, so the first LED, the simple LED symbol is very clear, and this is the LED symbol which is having anode and cathode leads. Okay, so if you are not indicating these arrows, it is become a diode. Okay, so this is a symbol of LED. Okay, and LED full form is very clear, light emitting diode. So this LED has its own characteristics. Okay, so whenever you are interfacing with microcontroller, so in previous reset circuit explanation I discussed about the voltage and current characteristics of two individual components. Okay, so in electronics, whenever you are trying to connect the two different devices, it is very important for us, you should be very clear on this voltage and current characteristics of two individual components. Okay, so it is not always microcontroller and LED. Whenever you are connecting any electronic device, so it should be very careful on these voltage and current characteristics. If this current and voltage characteristics are matching with both, then you can connect each other directly. If any parameter is not matching with one device, so you should take care of the complete electronics engineering fundamental knowledge. So why you need diodes knowledge, why you need resistors knowledge, why you need capacitors knowledge, inductors. See, every electronics active and passive component which will come into the picture whenever you are connecting two devices. Okay, so because if you open any application board, you will find resistors, capacitors, ICs. So there are so many amplifiers, boosters, so transistors, and these are all the different component knowledge why you need compulsory here. So whenever you are connecting each other, because some components will amplify the voltages, amplify the current, and some components will regulate the voltage and regulate the current. So this is the reason you need to use so many active and passive components in between two devices whenever you are connecting each other. So then only that the proper circuit will become interfacing circuit. Now, so even for LED, so you are trying to operate LED with microcontroller, you have to take care of these characteristics. Not only LED case, even you are dealing with motors, you are dealing with displays, you are dealing with any kind of application. So it should be very important for us, you have to take care of this voltage and current characteristics of two individual components. Okay, so in LEDs are used in different ways, whereas in traffic signals, indicators, and the dancing LEDs, there are so many LED formations like in decoration systems, top to bottom and bottom to go. As a viewer, it look like that LEDs are moving from bottom to top or top to bottom. Okay, they are not moving, just the operation which is shifting from one LED to another LED. Okay, and so for LED RGB formations, so RGB is also like this is the one combination they are using in multiple applications. Okay, and LED characteristics are very clear. Coming to voltage, so whenever you are trying to operate a small LED, the basic LED operating voltage is very clear, which is 1.8 volts DC. And coming to I parameter, which is current, so which requires from 5 to 10 milliamps current. So these are the two characteristics of LED. But coming to microcontroller is working with different operating voltage. So microcontroller, in our case, this is your microcontroller and this is your LED. So whereas microcontroller VI characteristics are, so microcontroller voltage is 5 volts DC and current is, so they are providing up to 10 milliamps max. So these are the two characteristics of voltage and current from microcontroller. Whereas in LED, so which is 1.8 volts and 5 to 10 milliamps current. So these two are very important known characteristics of LEDs with LED and microcontroller. Now I am trying to interface LED with microcontroller. Then what is the precaution you have to take care? So most of the cases, whenever you are trying to operate LED with microcontroller, it's very simple. They are attempting for connecting resistors. So why you need this resistance? So this is very clear, because of high current and voltage. To protect your LED from high voltage and high current, so you need resistor compulsory. Okay, so that is the only reason you are trying to connect one resistor in series with LEDs. So that's what you need to notice whenever you are connecting LEDs with microcontroller. So they may use resistors in series, okay, because of not matching these characteristics. If you are not protecting your LED, if you are connecting directly with microcontroller, it may damage your LED. So this is the simple LED interfacing circuit with microcontroller. And so what is the simple logic, or what is the embedded C program you need to write down for LED operation? So whenever you are looking to operate LED with microcontroller, so you are trying to explain all these applications. I'll write one by one, and I'll check the output also. Even I'm trying to do a simulation applications in continuation with this training. Okay, so I'll upload all simulation videos along with my recorded sessions. Okay, so please watch and subscribe my channel for getting more applications. Okay, so this is a basic hardware explanation with LED and microcontroller. Now I just want to write a basic program how this LED you can operate with microcontroller. So this is the program. I am writing embedded C program, which is hash include reg51.h, and so I am using this S-bit special data type in embedded C to declare one IO pin with a user defined name. So LED equals to P1.0. So wherever you connected your LED with microcontroller, so you need to declare the respective pin in the program, and then main. And so I'm trying to keep LED assigned with logic 0, because by default all IOs logics are ones from microcontroller, and whenever you are making logic 0 here, the initial status of LED is off. And if you are trying to make it LED operation, so you should take one variable compulsory. So that variable you need to declare with int data type, because the external peripherals whatever you connect across with microcontroller, so they need some time to respond. So because even if I am giving supply to LED, it doesn't turn on directly. If I remove the supply across LED, it doesn't go off directly, because it has its own response time. Always peripheral have their own choice and peripheral have their own response time, so that you need to provide time delays in between logic change. Okay, so why you need these delays in between peripheral operation compulsory? Because they have their own response time. But microcontrollers are very quick. They are executing your instructions with microseconds fast, but your peripherals are not responding with the same time. Okay, and then I am taking one infinite loop, which is while of 1, and making LED logic 1 and taking self for loop for delay generation. So the self for loops you can use for delay generation in embedded C programming. So whenever I terminate my for loop with semicolon, it means it is a self for loop, and making LED logic 0. And even for logic 0 also I need to wait the same time, and again I am taking the self for loop and closing while and closing main. So because of this simple LED program, your LED is operated from microcontroller on off with some time delay. So this is your simple program, and now I'll continue in next session. I'll continue how to manage traffic signal with microcontroller and RGB formations with microcontroller, and so how to manage different indications according to application. Thank you. Thanks for watching.